Good morning. Hello, my dear. So, I don't know if this is good morning or good evening for you, but for me, this is good morning. So, today in this video tutorial, I'm going to share with you gate, sprue, and few gate problems, gate numerical problems, not theoretical. Those already asked in gate previous year papers. Okay, basically, this tutorial I'm creating because to help you to understand its basic concept of gate and sprue design, and of course that's so of course you can solve numerical problems because my focus would be about 80% on numerical problems. That's why you will not face problem to solve numerical problems, right? So basically, as you know, what is gate? Oh, this one is not working. Okay, so what is basically gate? Okay, so basically gate, what is gate? I should share with you first. Suppose that we have a mold. I mean, we have to cast this part, right? We have to do casting of this object, so we'll create mold and all that, but we have to pour molten metal. That could be anything, maybe ferrous metal, non-ferrous metal, that is depend on us what type of casting we are doing. So for pouring this molten metal into this cavity, we required something that is known as sprue, basin, as well as gate. But basically we studied about sprue and gate in this, right? So what I'm and of course runner, we have to design also runner. So but most important for gate point of view, most important is gate. For gate point of view, I mean for gate examination point of view, most important is design of gate. And of course their types and what types of gates are there, I'm going to share with you in this video. So stay tuned and keep watching what I'm sharing with you. So first of all, let's go for the most important topic, that is sprue. Basically we start this thing with from sprue, right? So for understanding sprue and all that, I will go for a diagram. That is, I must say that elements of gating design. I'm going to share with you all elements of gate design. So let's go for that that diagram. So suppose that we have this one and this and this. So will this one, then we have to go with runner, then skip bob. I will share with you what are these things, that's why it will not face problem, right? We have to part this one, and then suppose that this one is our main cavity, okay, and this supporting elements is here, and we have to close this one, right? I hope you understand cope and deck and casting, all those things, but I'm not going to share with you cope, drags and cheek and all that. Yeah, so I'm going to share with you all important elements we used in case of this. Okay, so I hope I've done this now. So we have drawn this. Here I'm going to share with you all important elements. So first is this one is known as pouring basin, that's why you have idea. And this one is known as strainer, and basically strainer is made up of ceramic material, so don't get confused with this. And this is known as sprue, and this one is known as gate. And about these two topics, I have seen their number of times they have asked question, right? And this is known as splash core. This is known as runner, and this one is known as skip bob. Yeah, and last one is cavity, and this one is a riser. So basically this is the element. So we have pour molten metal here, then it will go here, from here to gate, and then riser, it will go out. So this is why riser is providing, because of shrinkage allowance and all that. Okay, so this is all about theoretical part. I must share with you, that's why I am sharing. And now I will go for the most important part, that is gate. But before going to share with you design of gate, let me share with you what type of basically we are using a sprue, and what are main important things we need to remember. Suppose that this is height of sprue, Okay, now this is 2 and this is 3, entering and the exit point. Now here one important formula, not one exactly, two important formulas we need to remember. If you are saying this is the height of base, you can say. So here 2 entering and exit is 3, so we can say at 2v2 is equal to a3v3. Okay, this is the one thing. Now if we'll say its ratio a2 by a3 is equal to a2 is equal to 2g ht, that means it's total height I'm talking about, ht, and a3 is 2g h, you can say b1, it's b1. Okay, so this is how you can relate things with, but because why it is happening, because v3 by v2, it's v3 and it's v2. So this is the formula we need to remember, but most important formula is we have to remember that velocity is equal to 2gh. This is most important. From these two will be, these two we can easily make if we know velocity is equal to 2 root under gh. Why it is happening, let me share with you how is it happening. Okay, we can, velocity, the unit of velocity is meter per second in SI, right? Just I am making you understand what is it. G root under, keep it root under, g acceleration due to gravity, its unit is meter square per second, right? So, and yeah, no, sorry, meter per second is square acceleration, and then h height meter, so root under meter square per second is square, what will happen, meter per second. What exactly, it's velocity. Yeah, I know that the unit of speed is also meter per second, but here we are talking about velocity only. So this is all about the simple concept of gate, not gate exactly, the simple elements, all that. Now we'll go for the gate and types of gate. I have shared with you what is gate. Basically it is going molten metal is passing through this gate to the cavity. Now we'll go for types of gate. What are types of gate? Basically we need to know, we'll go for that. Okay, I need I need one other paper, I think so I should get here, right? Just a second. Yeah, what exactly I'm doing. Yeah, I got paper, some paper I have to get to share with you. Yeah, I got this paper. Now we'll go for types of gate. What are types of gate? Basically, if you have gone through little bit through any book, then you will see there are many types of gate. So basically there are 4 types of gate. Top gate, what are these? I will share with you. Bottom gate, parting line gate, and stab gate. These are 4 gates, types of gates. If we're talking about top gate, bottom gate, parting line gate, and stab gate. If you now I'm going to share with you what are about this gate and what you need to remember if you wanted to have basic concept. And for getting numerical point of view, this top gate, from this top gate I have seen most of the time they have as question. Most of the time they have as question from this top gate only. But bottom gate is also important because it is having few formulas too, just like top gate. And parting line and stab gate, probably they will ask you application of it. Yeah, they will ask you only application, nothing else, from parting line gate and stab gate. So don't get confused in that. Yeah, in case of top gate, what exactly we do, we provide the gate at the bottom of the sprue, right? So suppose that we have a sprue here, and this is sprue. Will provide gate here only before the cavity. This is known as top gate. If we are talking about bottom gate, then we'll provide at the bottom of the sprue, not at the sprue, bottom of the cavity. So suppose that this is a cavity, right? So we'll provide gate arrangement here, and of course we have to provide runner, then this one, and this like this. Yeah, so that's it. 1, and this one is 2, and you must say that this is HT. So we consider this is gate. So this is known as bottom gate. We will provide the gate bottom of the cavity. Okay, so from these two, top gate and bottom gate, These two are most important for gate point of view. Okay, now we'll go for parting line gate. If you're talking about in industries and casting industries, most of the time they are using parting line gate. So don't be and why they are using, I'm just going to share with you. But they are using casting industries are using parting line gate to get the advantage of top gate and bottom gate. Okay, because through top gate maximum velocity with maximum velocity metal can be filled. That means it will take very less time to fill molten metal in the cavity. Now if we'll talk about bottom gate, then there will not be any maximum velocity. Of course, the molten metal will be having negligible velocity, and it will filled. That's because of pressure, because of pressure, you can say. So and of course there won't be any turbulence happen or erosion happen, and maybe splash, the cavity will not splash away. So if we'll talk about what type of application actually we have, for top gate, we usually use top gate for ferrous material for using ferrous, and bottom gate we use only non-ferrous. That means in which material we don't have iron atom, or iron atom, you can say that, just like aluminum, right? So this is this one, you can say cast iron, use this maximum velocity. We can fill the molten metal into the cavity with maximum velocity. Okay, so this is top gate and bottom. Parting line gate we use to get advantage of these two types gate. What is it? Let me share with you. Suppose that this is cavity, right? So in this cavity, what exactly we are doing? We just parting with. Okay, so what is happening here? You can say that this is like this, and if you say okay, then suppose that we are using this. Yeah, or this one is not parting, this one is okay. So this one B, suppose that this is A, suppose that, and here this is a height. So what exactly we're doing from here to here? Suppose that this is a gate. Okay, so for A part it is acting like top gate. And for B part it is acting like bottom gate. So if we are using parting line gate, that means we are getting advantage of both gating system. Both gating system means top gating and bottom gating. Now if you're talking about step gate, now what is the application of step gating system? Basically, step gating system we used in case of very large size product. If we wanted to cast any very large size product, then we have gone through this step gate. Okay, so step gate means there are many gate would be there in single cavity. So for filling single cavity there would be many gate, just like one gate would be here, one here. So these are a step gating system. So now most important thing is that we use type of gating system. It is also depend on what we have to cast. Simple, right? What we have to cast, based on that we used these gating system. That's why we are having these types. Okay, because if we used only one, what's the use of having all gating system? So these all are having own importance. So top gate, we if you are talking about gate examination, then top gate is most important, and bottom gate is little bit important because it is having few formulas. So right now what I am going to do, I am going to go through few formula. I am going to share with you few formula. Those are most important. Once we'll go through those formula, then we'll go for problems. So what problems in gate examination already ask. Okay, so let's go for those concepts. For this again I need you need a paper, good paper, white paper. Yeah, so let's go for those formulas. So first of all we are going to talk about top gate. So in case of top gate, we required few formulas. Those are most important, or of course you need to know. So basically, what they have been asked in gate examination, I have seen most of the time they are asking that how much time how much time will it take to fill the molten metal, fill the cavity by molten metal? Most of the time, that means they're asking about time, and for this I have a formula, that is T is equal to, for top gate, suppose that for top gate, AM VM AG 2H G. Here AG is area of gate, AM is area of mold or cavity, area of mold, and V is velocity. V is it's velocity, it's area, and 2G, yeah, it's, I'm sorry, it's not VM actually, it's HM. Okay, so this is height of mold. So actually what happened, if you multiple AM into HM, then what we got, volume. Area into height is known as volume. So that is the important, that's why I have written VM also there. So it's VM AG into 2GH. So this is for gate only, and this is for mold. I mean all these elements for mold only, and this is for gate only. So this is the formula we need to use for solving problem in top gate. Now let's go for bottom gate. Okay, again I should share here only bottom gate. So what formula we used in case of bottom gate I should share with you, right? So let's go for that bottom gate formula. TF is equal to TF, suppose T field for bottom gate, B for bottom gate, 2 AM AG area of gate 2G into, I should use different pen, into, this is multiple, this one is not working, yeah, this one is working, root under HT minus HM. HT means total height, this total height, okay, and HM means height of the mold. Now there is a case, if HT is equal to HM, means total height is equal to height of the mold, then we can say that to time required to fill the bottom gate system is equal to 2 into time required to fill the top gating system. Time required to fill what field? The molten metal to be filled in the cavity. Okay, so time required for bottom gate is twice if ST equal to HM. Okay, so that's why we can say that bottom gate system required more time as compared to top gate system. So this is the thing we need to remember. I mean, this is, maybe they can ask in MCQ. Okay, so this is all about top gating system and bottom gating system and formulas too. Now what I am going to share with you, I am going to share with you numerical problems, those has been asked in gate. That's why you can do much better, right? So are you ready? I hope you are ready to learn those numerical problems. Then what are you waiting for? Let's go for it. Yeah, right now what we have a question that has been asked in 2012 in GATE 2012 examination, and this question has been asked for 2 marks. Remember that this question has been asked for 2 marks, and the question you can solve easily within 2 or 3 minutes. Just we have to read the question carefully and go through it. Okay, so what we have to do, we have to read the question first carefully. That is, a mold having dimension of 100 mm, 90 mm and 20 mm. So let's write volume of the mold VM is equal to 100 into 90 into 20, and of course its unit would be millimeter cube. Is filled with molten metal through a gate height H, and cross section area AZ is A. Okay, the mold fill time is T1. So this is the case, and it is taking time for T1. Now what is saying, if height is now quadrupled, means H is equal to 4H. That means suppose the total height is equal to 4H, and the cross sectional area is half. That means AZ is equal to A by 2. This is for, suppose that this is case 1, and what writing I am here, it is for case 2. Okay, now this is it. Now let's go for the numerical problem. What is saying, the condition is this. Now what we have to find out, the corresponding filling time is T2. Okay, for this we are having filling time T2. Now we have to find out ratio T2 by T1. So what is T2 by T1? Okay, so we know that they did not say that what type of basically gating system they are using. So definitely if they are not not telling you what type of gating system you must use, then what you should do, you go for top gating system. Okay, so it is here T2 by T1 is equal to, okay, suppose that what is T1 basically, VM AZ into 2GH. This is what T1. Now V1 VM, suppose T2, for T2 what happened, VM same, volume is same, AZ2 into 2GH T2. Okay, so VM is same again, AG1 multiple 2GH T1. So VM get cancelled. What happened? This will go upside. So AG1 2GH T1 divided by AG2 2GH T2. Now what is AG2? Basically half of AG1. So AG1 2GH T1, AG1 by 2 multiple 2G. What is HT1 basically? 4H. So 4HT1. So H, okay, this is the comparison, right? 4HT1. So what happening with here? This is cancelled. Now if we will write this, simplify this, what we'll get, 2GHT1, we got half here, so 4, if we'll go take out this 4, then what we got, 2GHT1. So 2 get cancelled, this one cancelled. So answer is 1. So they should be what? C is the right answer, that is 1. So this is how you can solve numerical problems related to it. That's not all, my dear. I am going to share with you more numerical problems. That's why I will not face any kind of problem. I am going to share with you 3 or 4 numerical problems in this topic only. That's why you can remember what I have shared with you, those formulas basically, because if you are preparing for GATE, then formulas play most important role than practice. Okay, so let's go for the next numerical problem. Alright, my dear, so we got the next problem here. So in this problem, what we have given here, a mold has down sprue whose length is 20 centimeter. So just keep writing, length is equal to 20 centimeter, right? And cross sectional area at the base of the down sprue, that is cross section area, that is length means height, area is 1 centimeter square. The down sprue feeds a horizontal runner leading into mold cavity of volume, that is volume mold cavity 1000 centimeter cube. The time required to fill the mold cavity will be, we have to find out what time required. As I have shared with you in the beginning, pretty beginning of the video, what they will definitely ask you, time required. So most of the question they have asked in GATE, how much time will it require to fill the cavity by molten metal. This is the main thing, this is the main concept we need to grab to crack questions of GATE. So what is the formula for finding out time? Time required for filling the cavity is equal to volume of the mold, area of the gate, 2GH height, right? So volume is 1000, area is 1, 2G, just leave it, 20. Now here you are going to make mistake. What is that mistake? You will just put G is equal to 9.1 and you will not see the unit is meter per second square. So what you have to do with 9.81, you have to change its unit to meter, not meter, it's centimeter per second square. So you have to multiply with 100, then only you will get right answer. If you will not do this, believe me, probably one of answer will match and you will mark the wrong answer, and other than getting marks you have to give marks. So don't do this. Okay, so most important factor is that you have to remember unit also, what unit you are doing. So 2 into 20 into 9.81 into 100. So 1 by 2 is this much. So 1000 divided by answer is 5 point, the answer is 5.048 second. Okay, that the given unit is in the required time we have given, so this will come in, we are taking second, so it will come second. So 5.08, 5.0, okay, 5.045. so answer is here 45 means if you get 5 here 05, so answer is 2. So second option is the right answer. Probably if you are watching time, for solving single problem, you will not even take, it will not even take 2 minutes. But the thing is that you have to remember all formulas in your mind, and to remember all formulas in your mind, only remembering is not the key. The key is that you have to practice a lot numerical problems. Okay, so let's go for another numerical problems. Probably you are enjoying all tutorials, that's right, because I am making these videos with full of joy. That's why I am sure you are enjoying all these tutorials. Then what are you waiting for, my dear? Of course you are not waiting, I am waiting. So definitely I will share with you next question. Let's go for it. Alright, my dear, so we got another question here, and this question also asking gate. So what you need to solve this question, you need formula and of course calculator. Without calculator it will become little bit difficult for you to solve. Not for you, for all maybe. So the height of the down sprue is, height is 175 mm, and its cross section area at the base, AZ is equal to 200 mm square. The cross section area of the horizontal runner is also this. Okay, so assuming no losses, indicate the correct choice for the time second required to fill the mold cavity. So volume is again given 10 to the power 6 millimeter cube. Unit, you have to check unit, right? And we have to find T, time take to fill the cavity. Okay, T, again they are asking T. See, I did not get this question from my own. I got this question from previous papers only. From internet I got all these. You will definitely find out all these questions from their official website too. So we have to find out T. So what is the formula for T? Vm Az root under 2gh. Here again you are going to make mistake, because g is equal to 10 meter per second square. So you have to convert it into mm. Then 10 to the power 4 millimeter per second square. Don't forget to convert this unit, because they already have given this unit. That means they want you to be confused in this, and you will make wrong answer. So you have to be careful. Now Vm is equal to 10 to the power 6, Az 200, it's 2g 10 to the power 4, h is 200. Now what you required? You required calculator. Don't worry, I'm just going to use it. So 2 into 10 to the power 4, sorry, it's 10 to the power 4 into 200. Okay, 1 divided by 2, what we got? 2000. Probably I'm doing right. So this one, so 10 to the power 6 divided by answer is 2.5. Is this 2. Am I doing anything wrong? I don't think so. Okay, so this one is not, h is 175, right? And this one is right. Now it's okay. So what we have to do, 2 multiple 10 to the power 4 into 175 is this, so divided by 2 is this, multiple 200 is this, and 10 to the power 6 divided by answer. So what is the answer here? You can see 2.67. okay, so time is seconds. Okay, so this will come 2.67 seconds. So D is the right answer for this question. Okay, so what you have to do, you have to just remember this formula, and you need to know how to implement things in this formula. Once you will come to know, things will become quite easier for you. Okay, another problem I'm going to share with you in this topic only. That's why you will have command, right? And in this question, what we have to do, we have two questions given under this question, and the question is almost same. There is nothing rocket science like. They don't have given any rocket science. It's simple, right? So first of all, what we have to find out, we'll go through it. But first what we have to do, we have to implement the concept which I am just going to share with you. Okay, till now I have shared with you few numerical problems. Well, after solving few numerical problems in any topic, don't use, yeah, of course I can recommend you because it is benefiting me, probably it will benefit you also. See if it will beneficial for you, then use it, otherwise use your own. I'm sharing you the concept I am using these days, that is after solving, yeah, of course I have told many of my students to implement this, they have implemented, they got benefit. So what is the concept? What is the concept? The concept is here. Concept is this: you have to implement it, but you should implement after solving few problems in a topic. That means you know the formula. First, find out what you need to find out in the numerical problem. So in the first question, what we got? Volume flow rate. That means we have to find out volume. Volume flow rate means it is given its unit millimeter cube per second. Its unit is here. What is millimeter cube per second? Its formula is 2g and into h. 2g into h, its velocity. For finding out velocity, 2g into h. Now what we have to do? We have to multiply this velocity with area to get this one. To get what? Volume flow rate. Because velocity meter per second and area meter square, what will get? Meter cube per second. If we'll do this in mm, then it will be millimeter cube per second. Getting my point? So first of all, what is our motto? To get velocity in millimeter cube, millimeter per second. So what is the formula for finding out velocity? 2gh. So what we have to do? 2g, what they have given, or what I have taken, take g? No. So therefore I will get default this 9.81 meter per second. I have to convert into millimeter. Okay, 10 to the power 3, this has been converted into millimeter because 1 meter equal to 1000 millimeter, we know that. Now h, what is the h here? That is height. How much height is here? How much height we have given? 250. Remember that. So 250. Now what we have to do? We have to multiply 9.81 multiple 10 to the power cube into 250 is equal to this much. Yeah, 1 divided by 2 is equal to this much into area. Area is given. Is there anything? Yes, they have given diameter. So area would be pi by 4 into d square. Multiple pi divided by 4 into d square, that means 10 mm. 10 square is equal to, there is something wrong, right? Okay, double multiple, yeah, you can say, yeah, this is the answer we got here, and probably I am making some mistake here also to write. So let's go for it. Calculation mistake. After calculation, here is the answer I got, that is 173, and you can see here 17. So if we'll just do it from here 3 to 5, 1.7 into 10 to the power 5, right? If we'll divide this 10 to the power 5, then what we got? 1.73. So right answer is here C. So this is how you can find out the volume flow rate. Okay, calculation, sometimes calculate mistake, or sometimes typing mistake. Okay, here is it. The mold filling time is in seconds. We have to find out time. So time is Vm, of course, Vm volume, okay, the volume of the cavity, by AZ, area of the gate, 2gh. So Vm, what would be Vm? That is important. Now we know it is what? It is a cubical form. So this will become LV into H is equal to 100 multiple 100 multiple 100. So 10 to the power 6, right? So this will become 10 to the power 6. AZ, area of gate, pi by 4, 10 to the power square, because 10 is diameter we have given in this question. So what we got here? Multiple 2 into 9.81 10 to the power 3, 250. So what we can do, basically we can get from this here also, because we have already done this, right? So what we have to do, we have to just divide 10 to the power 6 divided by this one, 1.7 into 10 to the power 5, right? Okay, so what we got, 5.88. 5.88 we are getting answer here. So this is the answer. 5.48 is here because we are getting, because probably we did not take, after 1.7 we did not get values, that's why we are getting this one. If we have taken up to, I mean, 4 values up to values up to 4 decimals, then probably we could get the right answer, I mean the exact answer. This is the right answer. So this is how you can find out numerical problems what they have been asked in GATE. So I hope this one of the this one of the lengthy tutorial, so it is really difficult to concentration. If you are watching till now, thanks for watching. You have great patience, and just go for it. You can do something. Bye bye, and thanks for watching. Bye.